Welcome back to our series, exploring all this cool stuff in computer science and software engineering. And today we're diving into something that sounds, well, impossible, honestly. Running in the classic video game Doom. But get this, entirely within TypeScript's type system.
Yeah, exactly. It's not like we're talking about some port or like emulating it or anything like that. This is Doom, like the actual game running on the power of, well, types. The stuff we usually just think about for defining data in our code.
Okay, I'll be honest. I'm super skeptical right now.
Okay.
And, I think our listeners probably are too. It sounds like, well, an elaborate joke, right?
I get it. I totally understand why you think that. But trust me, this is a real project. It's massive, actually. We're talking about 3.5 trillion lines of code, 3.5 trillion,
Right.
177 terabytes of data. And just to render the first frame, it took 12 days of processing.
12 days for one frame. I mean, most games we're playing are rendering like, what, dozens of frames every second.
Yeah, exactly. But the thing is, this project wasn't about speed or anything like that. It was about, seeing how far you could push a type system, like, to its absolute limit. The guy who made this, he's, well, a pretty well-known TypeScript enthusiast, and he wanted to find that breaking point. Where would it just, refuse to rend?
So this is the same guy, right? The one behind all those crazy type challenge videos that, well, make even experienced developers kind of sweat a little.
Yep, that's the one. Clearly, he likes, a good challenge. But this is beyond just some complex type puzzle, right? This is like he basically built an entire virtual computer, but inside of TypeScript's type system.
Okay, hold on. A virtual machine, but made of types? I'm not sure I follow that.
So imagine, like, you're building a computer, but instead of circuits and chips, you're using, I don't know, Lego bricks. Right? Each brick is a type, and you're connecting them together. And somehow he made a machine that actually works. It has RAM, a CPU, a call stack, all the things a real computer needs.
Okay, so this Lego computer, how's it actually running Doom? It's not like, you just pop in a game cartridge.
Right. He had to translate every single piece of the game into types, the maps, the textures, how the enemies move, everything, all of that, encoded using nothing but TypeScript's type system. To pull that off, he had to implement some crazy stuff that you wouldn't normally even think about doing with types.
Like what? Give us some examples.
Well, for one, he made a garbage collector, for managing memory. Normally that's handled by, the language itself, not something you'd build within a type system.
That's wild. Okay, now I'm starting to see how this goes way beyond some, like, clever trick. This is like redefining what a talk system even is, isn't it?
Yeah, for sure. He also did things like he built a CPU cache to speed things up, a memory compactor to, use less memory, even a way to handle exceptions, all using types. The amount of creativity and, well, deep understanding of the game and TypeScript here, it's insane.
This is mind-blowing. But what about tools, right? How do you manage a program with 3.5 trillion lines of code? I can't imagine trying to debug something like that.
And that's where it gets even crazier. Most of the tools that developers use, they just couldn't handle something this big. Forget about things like syntax highlighting or auto-completion. Just loading the files into an editor was a challenge. It's like he was working in the dark, relying on his knowledge of the type system and, I guess, a lot of trial and error.
So not only is this pushing TypeScript to its limits, but also, what a human can even code and manage. But if the usual tools didn't work, how did he even know if things were, well, working correctly?
Well, think about it. It took 12 days just to render one frame.
Right, but how did he even know that one frame was right? Was he, like, just staring at compiler output for 2 weeks?
He had to come up with some very creative workarounds. So the final output of this program is actually, it's a TypeScript object. And each value in that object represents a pixel on the screen. But TypeScript doesn't have any way to, visualize something like that.
So he had to build that too. There seems to be a pattern here.
Exactly. He made a separate program just to take that output and turn it into an image file. It was like building his own debugger from scratch.
Okay, I'm officially speechless. This is less like programming and more like some kind of performance art. But I have to ask, why even go through all this? Was there a goal besides, just proving it could be done?
That's a question we're going to dig into in the next part of our deep dive. Because this project wasn't just about, technical wizardry. It was about challenging assumptions, pushing the limits of what we understand, and maybe even seeing a future where the lines between code and data start to blur.
Yeah, this is definitely a lot to take in. I think we all need a moment to, let it sink in before we keep going on this incredible journey. Stay tuned because we're just getting started.
Welcome back to our deep dive, into this crazy world where Doom is running on TypeScript types.
So, I'm still kind of wrapping my head around all this. We've covered, like, the how
Yeah.
part, the mind-blowing technical stuff. But I think it's time to talk about the why. What made him decide to spend, like, a year on this, this coding odyssey?
It is fascinating, isn't it? I mean, at first glance, you might think, oh, this is just someone showing off, right? But, I think there's something deeper going on here.
Okay, I'm listening. Tell me more.
So his original goal, it wasn't actually to get Doom to run. He wanted to prove that it couldn't be done, to find like that fundamental limit, that brick wall that would stop Doom in a type system.
So it was like he was trying to debunk the whole idea.
Yeah, exactly. But here's the thing. With every roadblock he hit, every like impossible obstacle, he found a way around it. And, instead of confirming his initial belief, it's like these challenges, they just made him even more determined.
So wait, so it's like a self-fulfilling prophecy. The more he tried to prove it couldn't be done, the closer he got to actually doing it.
Exactly. And I think this tells us something important about, well, about innovation in computer science. We often set limits based on, what we know, what we think is possible. But this project, it shows us that those limits, they're often, self-imposed.
Yeah, it's a good reminder. Sometimes you got to question what you think go outside that comfort zone,
Mm.
and you might discover something amazing. But let's be real. This project, it involves some pretty extreme measures. Turning off safety checks, pushing the hardware to the edge, and writing code that's, like, impossible to debug.
Yeah.
That's not how we're supposed to build software, right?
Oh, absolutely. This is definitely not like a how-to guide, right? It's not about like building real-world software this way. But that's not the point. This is about, exploration, pushing the limits, seeing what's possible. And in doing that, maybe we uncover new knowledge, new insights that could have a big impact down the line.
So you're saying even though we won't be seeing, like, type-powered operating systems or video games anytime soon, maybe the ideas behind this project, that they could change how we think about programming in the future.
That's the idea. Imagine, right, being able to use a type system not just to catch errors, but to like formally verify that software is correct. Like think about flight control systems or medical devices, right? Or imagine generating highly optimized code just for specific hardware, through the power of types. It's pretty mind-blowing.
Yeah, I can see that. It's pretty compelling. And I can see how this kind of, creative problem solving, the deep understanding of type systems here, it could lead to those kinds of advancements.
Definitely. I mean, this project, it highlights a trend that's been growing in computer science.
Yeah.
People are starting to see that type systems, they're more than just, for defining data. They can be powerful tools for making software reliable and fast.
It's like we're starting to realize, type systems aren't just about data. They're about expressing logic and constraints and even like complex calculations,
Hmm.
but in a way that can be, rigorously checked and verified.
Exactly. And who knows, maybe someday we'll look back at this project and see it as, the thing that kicked off a whole revolution in how we use type systems.
Lots to think about, that's for sure.
Yeah.
But before we go too far into the future, I think, we got to acknowledge the human side of all this, right? This was a year-long project, tons of challenges, tons of setbacks. What kept this guy going? Like, what was driving him?
Well, he actually called it, and I love this, a self-inflicted nerd snipe, and a big one at that. It all started with this simple question, why can't Doom run on a type system? And that question became like this obsession, a puzzle he just had to solve.
So it was a mix of, like, curiosity and a love for a good challenge and maybe, a little bit of stubbornness.
I think that's a pretty good assessment. And in the end, it's that kind of passion, that dedication that drives innovation in any field.
It makes me think of that quote, any sufficiently advanced technology is indistinguishable from magic. And this project definitely feels like magic, taking a type system and turning it into, like, a virtual machine that can run Doom. That's incredible. But like we've talked about today, there's more to this story than just, technical wizardry. It's about pushing limits, challenging what we think we know, and, well, the joy of discovering something new.
I agree. And you know what? I think this story, it has the potential to inspire a whole new generation of programmers to look at type systems, with fresh eyes, to explore them, to see what other magic is hidden within.
Couldn't agree more. But before we wrap up this deep dive, I have one last question that's been on my mind. If we can do this with TypeScript, What other impossible things are hiding in other languages? What are we limiting ourselves to just because, we haven't explored the full potential of the tools we use every day?
Those are great questions, and questions that I hope our listeners will think about, The world of software development is full of, well, uncharted territory. It's up to us to go out there to push the boundaries and see what incredible things we can create.
Welcome back. You know, it's amazing, right? We've been talking about this crazy project, Doom running on types, and it's been quite a journey so far.
Yeah, no kidding. We've seen the technical side, right? Like
Yeah.
the how do they even do that part?
Yeah.
But to me, the really interesting part is the why. Why go through all this trouble for something that, well, most people would probably never even think about doing?
Exactly. We talked about all those technical challenges, but, what was the driving force behind it all? What kept this developer going?
He called it a self-inflicted nerd snipe. And honestly, I think that's the perfect way to describe it. It wasn't about, you know, being practical or building some real-world application. It was about, like, pushing the boundaries, challenging what we think is possible with a type system.
It's like the power of curiosity, right? That drive to explore, to just see if something can be done, even if it seems, well, kind of crazy.
Totally. And it's a good reminder that sometimes, the biggest breakthroughs, they come from people who just ask, what if? The ones who are willing to, like, step off the beaten path and explore the unknown.
And in this case, the unknown was the world of type systems, right?
Yeah.
We usually think of them as tools for like catching errors, making sure our code is consistent. But this project, it shows us there's like this hidden potential there, this power and flexibility that, well, I think we're just starting to understand.
Think about it. If you can build a virtual machine, like a real working computer, inside a type system, then, well, what else can you do? I mean, it could change how we think about software reliability, performance, even programming itself.
Yeah, it's like discovering the secret language, right? A language within the language, a way to express all this complex logic and stuff, but in a way that the compiler can actually check and verify.
That's it. And that opens up some incredible possibilities, right? For writing software that's not just more reliable and efficient, but also more secure.
So this project, I mean, it might seem kind of out there at first glance, but I think it gives us a peek into the future, a future where type systems are, well, way more important in how we build software.
Hmm.
They're not just about catching errors anymore. They're about making sure our code is correct, about making it run faster, and even about expressing like really complex algorithms and behaviors.
It's a future worth exploring, don't you think?
Absolutely. And I hope our listeners, they feel inspired to explore it too. Dive into the world of type systems, challenge your assumptions, and, maybe you'll be the one who discovers the next impossible thing. Thanks for joining us on this deep dive into the world where Doom runs on TypeScript types.